Hi guys, welcome back. So we're going to finish up our discussion of rational functions and polynomials by looking at inequalities and how to solve them. You might wonder where a function is positive or where one function sits below another. These are all involve solving inequalities. So we're going to look at how to solve those for both rational functions and polynomials. So let's head over and get started. All right, guys. So let's get started here. We're polynomial and rational inequalities. So let's start with this example here. Solve the inequality x squared minus 9x minus 22 is greater than 0. Now, let's think about this kind of more theoretically for a moment. I know that quadratics look like a parabola. So they either open up or they open down. I also know that in terms of real roots, they could have 0, 1, or 2. Now, here's the deal. In calculus, we're going to talk a lot about this notion of continuity. And so I'm not going to define what that means, but I think there's some intuitiveness to the definition. And essentially, what that means is this. If I have a 0 right here and a 0 right here, then when my polynomial, or in this case quadratic, goes through that first one, I know that it has to come up through the second one. And because it's quadratic, I know I've only got 2 roots. And in this case, 2 real roots. There may be a multiplicity issue, but not in this particular case. Which means that after I've hit that second root, once the function's above the x-axis, it's going to stay above the x-axis. Same with over here, okay? And so we're going to take advantage of what we know to be true about quadratics when we do this. So let's start by finding the zeros. So x squared minus 9x minus 22 equals 0. Well, this is x minus 11, and an x plus 2 equals 0. So I know that x equals 11, or x equals negative 2. Now, the next issue I can ask myself is this. Does this parabola open up or down? Well, notice that my leading coefficient, the coefficient of x squared, is greater than 0. So this parabola opens up. So if I've got these 2 roots and my parabola opens up, then I know that it must do something like this, okay? Right, it opens up and these are its zeros. So it has to go through the way I've drawn it. Now I could also find test points, because what happens is the roots create 3 intervals. So on negative infinity, negative 2. So pick a value. Let's say x equals negative 3. Well, if x is equal to negative 3, then y, well, let's think about it. Plug in negative 3. You're going to get 9 plus 27 minus 22. It's going to be positive. And then we could check out the next interval between negative 2 and 11. Well, there's a nice choice on this interval. How about 0? Okay, well, you plug in 0, you're going to get negative 22. So the function is less than 0. And then on my last interval, everything to the right of 11, I don't know, how about we choose x is equal to, 15? Well, if you plug 15 in, you'll get 225. Well, you're going to get, again, something positive, okay? And so now we know where this quadratic is positive. And so my solutions are going to be negative infinity to open interval, right? Not greater than or equal to 0, but strictly greater than. And oh, I'm sorry, negative 2. And then 11, infinity. Okay. Let's look at another one. 3x squared minus 13x is greater than or equal to 10. So here, what I want to do is subtract 10 from both sides, and we get this. And then we can try to factor this again. And so I think a minus 5 and a plus 2 is going to work. And so x is negative 2/3, or x is 5. Well, again, I know this opens up. So if this is negative 2/3, and over here somewhere is 5, my parabola opens up. So I know that we've got positive, negative, positive. And so I'm looking for where this is greater than or equal to 0. So that will be from negative infinity to negative 2/3, including, because it can be equal to 0. And then union 5 infinity. And again, 5 is closed because we're including 0 as a possibility. Okay. So notice that for the quadratics, at least, grabbing these zeros and then asking what, if it opens up or down, really tells us where the function is going to be positive or negative. What about this one? Here I've got f of x and g of x. I want to know, where is f of x greater than g of x? Well, let's think about what that means. Because hopefully from these last two, you're recognizing that we really need to get our hands on zeros. And so asking where f of x is greater than g of x is really like asking, where is f of x minus g of x greater than 0? And so we can do that, right? 2x squared minus 9x plus 1, there's f of x, minus g of x, 3x squared plus 11x plus 61 greater than 0. And so we have a negative x squared, and then negative 9 minus 11, so negative 20x, and 1 minus 61 be negative 60. Okay. Greater than 0. And I could factor a negative out. So get x squared plus 20x plus 60 greater than 0. And so now we want to solve this. So I'm going to do that by finding the zeros, right? Because I know that at wherever I find the zeros, I know that's where the signs change. And so you can try to factor this, or you might use quadratic formula. So x equals negative b plus or minus the square root of b squared, so 400 minus 4ac, so 80 times 60, all right, 4 times 20 times 60, all over 2a. Okay. And so let's see what we get here. So we're going to get this for with the quadratic formula. And what does this tell me? Well, this tells me non-real roots, which means this thing never touches the x-axis, right? It never touches the x-axis. So this quadratic, we know it opens down and it never crosses the x-axis, which means the whole thing must live where? Well, it must live down here somewhere. Who knows where? I mean, we could figure that out, but why? So is this thing ever greater than 0? No. There is no solution. Okay. All right. What about this one? Here's another inequality. And what I want to do here is we need to actually find the roots of the numerator and the denominator. Because again, we're looking for any place where the sign can change. So x squared plus 3x minus 4 equals 0. I'm going to show you how this works. This isn't going to be quite as straightforward as the other one, as the quadratics, but it's okay. Essentially, we're going to break up the number line into intervals. And because we will have found all the zeros and all the zeros of the denominator, then we know that whatever the behavior is on any interval, it's going to be that way on the entire interval. So let's get our hands on these. So factor. And then keep factoring. So we have minus 9 and plus 8. So we have 0 or 9 or negative 8. So what we've done is we've partitioned the number line. There's negative 8. Here's negative 4. Again, I'm eyeballing 0, 1, and then way out here we have 9, okay? And so what we're going to do is we're going to look for sign changes. And so I'm going to take a test point. And one of the nice ways to do this is you can actually take this, this rational function and write it in factored form. I think what that does for us is it lets us just take advantage of rules of signed numbers. So I'll show you what I mean by that here. Okay, so here's my first interval. Negative infinity, negative 8. So choose a test point. I'm going to choose negative 9. Now watch what happens. When I plug negative 9 into, and again, I'm always coming back to this quotient here. My numerator, well, negative 9 plus 4 is negative. Negative 9 minus 1 is negative. And then in my denominator, I've got x, which is negative. X minus 9, well, negative 9 minus 9, that will be negative. And negative 9 plus 8 will be negative. Again, I only care about the signs. And so if I simplify this, well, positive, and then my denominator will be negative. So this is negative. So I'm going to write a negative right there. And then let's look at the next interval, negative 8 to negative 4. I don't know, how about we let x be -5? Well, if I do that, I have a -5 plus 4, which is negative. I have a -5 minus 1, which is negative. And then in my denominator, -5, -5 minus 9, and -5 plus 8 will be positive. So here, I look at my signs, negative times negative. And then in my denominator, I wound up with positive as well, because positive times positive. So that is positive. Okay. We keep going. -4, 0. Okay. I'm going to choose the test point, I don't know, -1. Okay. And when I choose -1, I'm going to let you try this now. But it looks like we'll have positive times negative over negative times negative, and -1 plus 8 is positive. And so negative over positive is negative. So we're going to have negative. Okay. My next interval, 0, 1. All right, I'm going to choose 1/2. If I choose 1/2, let's see, positive times negative. So my numerator will be negative. And then positive, negative, positive. So positive times a negative will be negative, times a positive will be negative. So negative over negative is positive. So on this interval, positive. And then 1 to 9. I might let x be 5. And so we get positive, 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 negative, positive. So positive over negative, we get a negative. And then in my last interval, 9, infinity. Let x be 10. And here, everything will be positive. So we get a positive. Okay. So now I can actually write my solution, okay? So I'm looking for where this thing is positive. And so my solution, and I apologize for putting it down here. So I've got -8, -4, union 0, 1, and then union 9, infinity. Okay, there's my solution. All right, so really the summary would be this. Let's say this. 1, find all zeros of numerator and denominator, if there is a denominator, okay? And then test points on each interval created from number 1. Okay, that's the goal. And then once you've done that, you know where the function's positive or negative. All right. All right. So there we go, guys. Go ahead and practice some of these. Again, it's good review. You're going to have to be able to find zeros. Big picture, find all the zeros in the numerator and denominator if applicable. Create those subintervals, test points on those subintervals, and then you'll know where your function's positive or negative, and you can write your solution sets. All right.
Hopefully that went well for you and your studies are going well. I will check back with you soon. As always, have fun.